Let's analyze a situation with a dog pulling a rollerblader around a corner. So let's say that we know the length L of the rope. We'll be also given the speed of the dog, VB, and its acceleration, AB. So let's say that L equals 6.5 meters. Velocity of the dog equals 3 meters per second. Acceleration of the dog equals 0.2 meters per second squared. These are both in the positive x direction. And we can think about, is this realistic? Okay, so the dog is going 3 meters per second, so that's about 6 miles per hour, 10-minute mile. That seems reasonable. And since the dog is coming out of the curb, he's accelerating positively, but he is flinging the person around the curve. So we'll say that this here is the center of the curve and that the radius of curvature there is R. And so we also need to be given R. R equals, say, 2.5 meters. Okay, so if we extend that, we can make a right triangle here. So we know that this distance here is also R. And we know L. So we can find the horizontal distance between the dog and the person as well as the vertical distance. And let's just put our coordinate frame here. We can say there is X in that direction and Y in this direction. All right, so if we're given all of those things, we need to find speed of the person. And let's say it's a girl because the P and the D are going to look really similar. So just put a ponytail. Okay, so speed of the girl, or actually velocity of the girl. And then angular velocity of the leash. Acceleration of the girl. And angular acceleration of the leash. Now we know that the direction vector, since this is a two-dimensional problem in X and Y, the direction vector for omega and alpha are both going to be in k hat. It's always the case. So use the right-hand rule for that. So we know it's going to be k hat, but we don't necessarily know positive or negative, and we don't know the magnitudes. So what we need to do here is use the general planar motion formula because the leash in between them has general planar motion. The dog has a linear motion and the girl has a fixed axis rotation motion around this center of curvature here. And combine the linear, the angular, we get general planar for the leash. So first we'll write out the general planar motion equation. So let's go with our plan. So first thing we need to find is the distances and radius or length or position of girl with respect to dog. We need to get that. And then once we get that, we'll get the velocity of the girl with respect to the dog. And then we'll get velocity of the girl and omega of the leash. So those both will happen at the same time using the general planar motion formula for velocity. And then we can do acceleration of the girl and angular acceleration of the leash using general planar motion formula for acceleration. Because these are vectors, we'll get an x equation and a y equation for each. And so we can solve those two equations for two unknowns. Step one, we need to find distance. So let's get a different color here. We know the vertical distance here between the girl and the dog. So RG with respect to D, it starts at the dog and it goes to the girl. So it is this vector. Okay, so that is negative y, negative x. So We'll draw that vector here. And we can say that position of girl with respect to dog is going to be negative in the I hat, negative in the J hat, and the distance is R going down in the Y. So that is going to be 2.5 meters. And then in the I hat direction, we can either find that x coordinate by using the Pythagorean theorem or the distance formula with L and R, or we can recognize that this is actually a special triangle. So we've got a 5, 12, 13 triangle. So we have 5, 12, 13. And this one is analogous to it because we have 2.5 and 6.5. So this distance must be 6. Okay, so negative 6I minus 2.5J meters for R, G with respect to D. So now for velocity. Velocity of the girl equals velocity of the dog plus velocity of girl with respect to dog. And so we'll have velocity of dog plus the omega cross R, where this is R G with respect to D, and this is omega of the leash. Okay, and we're going to assume that omega is positive counterclockwise. So we'll say omega like that. Okay, so now filling stuff in here. So velocity of the girl, we know that the girl is going straight in the vertical direction. At this point, we will have velocity of the girl just because she is at that apex of the turn. So velocity of the girl is all going to be in the J hat direction. We'll use that to our advantage. And then equals velocity of the dog, which we were given is 3 in the I hat. And then plus, we'll write out our cross product here. I, J, K, 0, 0, omega. And we don't know omega, so we'll just leave it right there as a variable. And then the R, which we found above, negative 6, negative 2.5, and 0. Okay. So we'll bring this down. Velocity of the girl in the J hat direction equals 3I hat plus, now we do the cross product, which will be I hat times 0 minus negative 2.5 omega L. So that comes out to be 2.5 omega L. If you need to review cross products, click the link and do that. And then negative J, and that J component will be 0 minus the negative 6 times omega L. And so we have 6 omega L. All right, so now we can just group the I's and group the J's. So for the I's, we'll bring this 3 to the other side, and we have negative 3 equals 2.5 omega L. And in the J's, we have VG equals negative 6 omega L. So we'll solve the I equation for omega L, and then we'll solve the J equation for VG. Okay, so if we do this division, we get negative 1.2 radians per second equals omega L. And so that will be in the K hat. Okay, so that's 1. And now for VG, then VG is just going to equal negative 6 times the 1.2, which is 7.2 in the J hat meters per second. Okay. So we've got omega and v, and both of these check out because if we know that the girl is going in the vertical direction, so we have a positive j. We also know that the angle of the leash must be decreasing, therefore omega is negative. Okay, so this is one way to solve using general planar motion. There is actually another way that you can solve for velocities that is a little bit shorter, that it only works in this particular situation because of the special triangle, but we will go ahead and work through that. An alternative way to solve for velocity is to use similar triangles and ratios. So we'll do that over here on the right side. We know that V equals R omega. That is the standard linear versus angular relationship. So then omega equals V over R. So in our case, this is going to be velocity of the girl over position of the girl, or velocity of the dog over position of the dog. So we can solve this first one to get velocity of the girl, and then we can use either one to solve for angular velocity. Okay, so we know velocity of the girl equals velocity of the dog times position of girl over position of dog. So that is going to be velocity of dog is 3, and then we have times position of girl, which is that 6 meters in the x direction. And notice that this does not take signs into account, okay? So you do have to know which direction things are moving. This is just scalars. Okay, so position of girl, which was 6, is that distance, and then the distance for the dog is 2.5. And this comes out to be 7.2 meters per second equals VG. And we just have to know, because this is a scalar, we have to know that VG is in the positive J direction. So then plugging back in, we can find omega. Omega equals VD over RD, or it could be VG over RG, either way. And that will give us 3 over 2.5, which equals 1.2 radians per second for omega. And here, this gave us a positive value. We have to know that omega is going negative counterclockwise, or negative, it's going clockwise. And that's just because since the girl is moving vertical and the dog is moving horizontally, then that angle is decreasing, and so omega therefore must be negative. So that's the caveat with these shortcuts, is you have to know which direction things are going, because the shortcut works with scalars and we're dealing with vectors. For the next part, we're going to find the accelerations. So we need angular acceleration of the leash and linear acceleration of the girl. Now we know that the dog has all of its acceleration in the positive x direction. The girl is going to have a linear component of her acceleration and an angular component because she's going around a circle. So you have that centripetal acceleration and you have the rate of speed change. Sort of like with polar coordinates, you know, when something's going in a circle, you have the UR component and the U theta component. So we know that the girl is going to have a radial acceleration, and she's going to have a theta acceleration. So we need to account for both of those. So the theta acceleration will be the rate of change of speed, and the radial acceleration will be that centripetal one. So let's scoot down and then work the rest of it out here. Okay, so we know that acceleration of the girl is, if we put in the general planar motion formula, Then we've got acceleration of d plus acceleration of g with respect to d. Okay, so now using the polar coordinates of it, we can have, we know acceleration of g is going to have vg dot, so that part in the j direction for that a theta, and then plus vg squared over r in the I direction for that UR component. And then acceleration of D, which is given, and that's all in the I. Plus, we will have alpha cross RG with respect to D, plus omega cross R, G with respect to D. Okay, and this is alpha of leash, omega of leash, omega of leash. But this particular part, is velocity of girl with respect to dog, which we found here. Okay, so let's just write that over here. Velocity of girl with respect to dog equals 2.5 omega L in the I hat minus 6 omega L in the J hat. And so we have 2.5 times omega was negative 1.2 I hat minus 6 times negative 1.2 in the J hat. And that comes out to be negative 3 I hat plus 7.2 J hat is velocity of girl with respect to dog. So we'll need to plug that in to our cross product. Okay, so let's start putting in numbers now. So VG dot in the J hat, we don't know what VG dot is, so we'll need to just put it here as a variable. So VG dot in the J hat plus VG squared, which we had VG was 7.2, squared divided by R, which this would be radius of the curve, which is that 2.5 meters. And that's I hat and equals to AD, which AD we were given in the problem is 0.2 I hat plus, now we've got a cross product here, I, J, K, 0, 0, alpha, and RG with respect to D, which we had previously calculated to be that negative 6 in the I, negative 2.5 in the J, and 0. Okay, so then add the next cross product, I, J, K, and here we'll have 0, 0, and now we know omega was negative 1.2, and then the X and Y components from VG with respect to D, negative 3, 7.2, and 0. So now that we have as many numbers as possible, let's work this out. So we'll have VG dot in the J plus the 7.2 squared over 2.5 is 20.74 I hat equals 0.2 I hat plus, we need to do this cross product, I hat times 0 minus negative 2.5 alpha gives us 2.5 alpha minus J hat times 0 minus negative 6 alpha is going to be 6 alpha. And then the second cross product, then of course the K hat is 0 because everything's times 0. And then here we'll have plus I hat times 0 minus 7.2 times negative 1.2. And so that comes out to be 8.64, and then minus j hat times 3.6. Okay, so let's just check the signs on that. So we have that minus that, so that should be a positive, and then negative j times that minus double negative. Okay, so we need a positive here. All right, so now we can just work out the I hat and the j hat components separately. We got two different equations. So in the I hat, we'll just take the pieces. We have 20.74 on the left equals 0.2 on the right plus 2.5 alpha plus 8.64. So we rearrange this and we get negative 2.5 alpha equals 11.9, which gives us alpha equals negative 4.76 radians per second squared, and that is in k hat. Okay, so alpha is negative. Now, omega was negative. That doesn't mean that alpha has to be negative. They just happen to both be that. So then the j equation. Let's see, we have VG dot in the j hat equals negative 6 alpha plus 3.6. So that is negative 6 times negative 4.76 plus 3.6. And that equals negative 32.16 meters per second equals V dot. And actually, that's meters per second squared. Okay. So now we've got both the pieces. So if we go back over to the beginning and fill in total for acceleration of G, we'll have the VG dot in the J hat and the 20.74 in the I hat. So we'll have 20.74 I hat minus 32.16 J hat meters per second squared. That is acceleration of the girl. So the girl has a positive acceleration in the I hat because she's going around a curve to the right, so that makes sense. She is slowing down her velocity in the j hat direction. And does that make sense? Well, it should, that the vertical component of her velocity or her acceleration is negative, because if we scroll up here, currently all her velocity is in the positive j direction, positive y. So as she goes around this curve, less and less velocity is going to be in the y direction, more and more is going to be in the x direction. So it makes sense then that her x acceleration is positive and her y acceleration is negative because it's the direction of her velocity vector changing. So to recap for this problem, we were given length, velocity of dog, acceleration of dog, and radius of the curve, and we used the general planar motion formulas, just plugged in all the values that we had, and then we were able to split up into I and j equations and solve for unknowns from each. You can use shortcuts with scalars in order to solve for velocity and angular velocity, but because those are scalars, you have to be aware of what direction things are going, so you know to put things positive and negative and whether they go in I, j, or k.